Recording. Cool. Share my screen. Can you guys all hear me fine?
Yep.
Okay, cool. All right, let's get started. So this week's quiz and what you've learned about this past week has mainly been about mesh current. I know in the last review session I went over mesh current a bit, but it seems that this coming quiz will definitely be on mesh current. Judging from previous weeks or previous years, it's probably similarly to how the last quiz was two mesh current or two node voltage questions. This one will probably be either two mesh current questions or like one mesh current and one superposition question. So I'll really quickly go over what those two things are again, and I'll also go over Thevenin equivalence, but I'm not going to do a practice problem for that. So mesh current, as you hopefully know, is when you have a circuit and it has a couple different like obvious sections to it, right? Learned a couple ways to deal with circuits like this. I'm just kind of making some stuff up here. I can do that, I can do that. But one of the ways you can solve this circuit is you can use mesh current method. And with mesh current, what you do, this can be the current source. What you do is you make these, you take each different section of the current, each mesh as it was defined for you in some of the first days of class, and you assign to that some current that you're kind of making up or you're labeling. So it is best practice to always make all of these currents go in the same direction. So I'm making all three of mine clockwise. Here we have I1, I2, and I3. And what you do is around for each of the currents, let's say I1, I2, I3, etc. We're going to make a KVL loop. We're going to write the KVL equation for its loop. So in this case, I'll do that just for this I1 because it'll make more sense later when we do practice problems. So I'll just call this like V1. This can just be R, and this can be R1, and this can be R2. So just as an example, right, the I1 equation for this circuit here would be, we have minus V1 because the voltage is up in the direction of current, and then plus the voltage across that resistor R1 is going to be the value of the resistor. Remember, V equals IR. So that R is the same R. And then the current through this resistor, in terms of these currents that we have labeled, is going to be I1 minus I3. That's because currently the I1 equation is from kind of the perspective of I1. So right now we're saying I1 is positive. So that means since the current from I1 is going to the right through the resistor, then the current from I3 would be going the other way, which we can think of as negative. And similarly, we're going to have, for the next resistor, we have R2, I1 minus I2. And that would equal 0, because that's around the whole loop, it equals 0. Other things about, actually, I'll keep going with this example just because I added a nice little thing here. I will call this I1. When you are writing equations and you see a current source on part of your loop, that is very helpful. So what that tells you, well, if it's on the outside and only attached to one section or one mesh, then makes your life very easy. So for I2 here, right? I2, you could look at this and say, oh, we have like R3 and R4, yada, yada. But what we can also see, though, is that around I2, we have it go through this current source. And this current source is only attached to this I2 loop. And so what that tells us is we can just directly say that I2 is equal to negative I1. I1 is what I've decided that this is. And since we've defined I2 in the problem as going counterclockwise. That means since it's going down through this current source, and this current source is only affected by I2, that means that we can say that this current source basically is I2, which just since it's going in the opposite direction, it would be negative. And the same thing happens for dependent current sources if they're on the outside or if they're only attached to one mesh. So if you ever see that in a problem, it can make your life a whole lot easier. I'll do I3 as well. Can't hurry, it's gonna be like R5. And what you'll find is that this I3 loop is going to have some similar terms to that first loop that we wrote. I'll start with the R1 resistor. So it's going to have R1. Now it's going to be I3 is positive because we're looking from the perspective of I3. So I3 minus I1 plus, let's do R5 next. R5, and R5 is only affected by I3. So it's just simply R5 times I3. Again, V equals IR. We have R, we have I. That's going to be the voltage. And then the last one, we have that R, I think I called this R3. Can't really tell you that's a 3. R3 times I3 minus I2, 0. Solving this would be relatively straightforward. You plug in, assuming like I gave you values for the resistors and such, but you have I2 directly, so you can just plug that in for here and for here. That would simplify your equations a lot, and then you have 3 equations, 3 unknowns. You can solve that using enough algebra. So then the other thing about mesh current is that similarly to how we had a super node, we have this concept of a super mesh, where a super mesh, however, is going to be instead of, let me erase quite a bit. So let's pretend that this R2 was instead, I'll make this like, this can be another voltage source. Sure, this can be like V2. So let's say we had a current source in the middle. So now we have, I'll even make it like a dependent current source. It doesn't, I'll do a normal current source for now, just to make the example a bit easier. So now this is your I, I'll call this I2 now, or I'll call it IX. I'll just call it I, I'll call it I. So what'll happen here though, is when you're trying to make these KVL loops, you'll try to figure out the voltage of this current source, and there's no like easy way to do that. You kind of just have to make up, this could be like Vx, and then you just have to run with that in your equations. It would make your life hard. What we do instead is we define this bottom part as a super mesh. So that would be your super mesh. And the super mesh, did that not? Oh, I undid it. Come on. Made such a nice circle. Okay, there we go. So you have your super mesh. And the super mesh, if you remember, with node voltage, a super node was when you had 2 nodes connected by a voltage source, and you would call that one super node. Here, instead of 2 nodes connected by a voltage source, it's 2 meshes connected by a current source. So that bottom one would now become a super mesh, and we basically ignore that branch with the current source. We have the I1, I2 super mesh equation, I'll call it. And that would be going around the circle. We're still going clockwise around. Or no, we're still going counterclockwise around. And again, I'll start at that V1. So we'd have the negative V1. And then we're still going to be using that I1 and I2. It's just we're only writing one equation for it. And then we'll write another equation to relate I1 and I2 later. So just like before, it's going to be V1 plus that R1 times I1 minus I3. And then plus, and now see we're skipping the current source and going straight to R3. So we have R3, I2 minus I3. And then to that voltage source, now it's going to be actually a plus V2, because clockwise, that is a voltage drop. And that is what we want for positive. And then finally, it'll have plus a the other way, just to be consistent, R4, I2. And that equals 0. And then you could write the I3 equation it's going to be it's going to be like exactly the same as the one above. I'll just kind of copy it to have it there for if people want to look at it later. I3, and then the relation equation, or I'll call it the relation equation. I'd like that. Relation equation is going to be, so if we look at this, right, we have that I in the middle. On this branch of the circuit, we have I1 going down and we have I2 going up. So what that tells us is that since this is big I, that is the current source, is going down, we can say that I equals I1 minus I2. And with that, you have enough equations to solve the circuit, basically. Now we have 3 equations, 3 unknowns. Every variable that isn't an I in this scenario, or isn't like this big I is supposed to be given. Everything else is known. You would have enough here. The key thing here is, remember, when you have the super mesh, it's when you have a current source between 2 meshes. And what you do is you write one big equation where you go all the way around, and then you write this relation equation between the current source and the 2 mesh currents. Okay. And then, okay, now I'll talk about superposition. I'll do like a very basic drawing here, and then I'll like I'll do a question about it later. So basically what superposition says if you have a circuit like this, I'll do like another one as well. And then we want to find out the voltage across this resistor. What we can do is we can split this into like 3 different circuits where we only focus on one voltage source at a time and ignore all the other ones. So actually, I'll just take this out because you can simplify that by just like it's in parallel with V1. Wait, no, that's not useful. Never mind. Okay, ignore what I just said. Anyway, yeah, you can split it into 3 circuits. And what you do is you neutralize the sources that you're not looking at, and then actually, yeah, wait, this breaks it. Okay, I'm just gonna have those other 2 sources because that current circuit, it would have the voltage of 0 for the voltage sources. Yeah. So we have our voltage source and our current source. We're gonna split it into 2 circuits basically where you neutralize the source and you take the voltage that you get from that, and then you basically solve 2 circuits and then add the results together. So what we were gonna say is for this left half, we'll focus on the V source, right? So this can be V1. Oh, actually, this example will be a bit more poignant and useful if I make another resistor here. So this can be R1 and this can be R2. So for this first circuit, right, we're going to neutralize the current source. When you neutralize a current source, you make it a short circuit. That is very important to know. If you short the current source, then your answer will be wrong. So here, the voltage across this R1, which we can call, actually this can be called VR prime because it's not actually VR. VR is for the total circuit. We're just finding VR prime right now. So that VR prime, by just like simple voltage division, is going to be R1 over R1 plus R2, V1. And so that would just be, that's our VR prime. And then our other circuit would be where we neutralize the voltage source and leave in the current source. So here, we're going to have, where we have I R1 plus minus VR prime prime. And so what we're ending up finding is that VR equals VR prime plus VR prime prime. VR prime prime. So here, we're looking at this. What's going to be the voltage across VR? Well, we see that these 2 resistors are in parallel. It might not look like that, but if you just kind of shoved this one down here a little bit, then it would look normal. The other key thing here, voltage sources are shorted when you neutralize them. So the voltage source becomes a wire, the current source becomes an open circuit. You can think of that kind of like what's the opposite of what they currently are. So a voltage source makes a separation, like it makes a difference in voltage. A wire, by definition, like has no difference in the voltage between here and here. So the voltage source is going to be neutralized by making it so that there's no voltage difference on either side of it. Whereas the current source, it provides a current. If you break the circuit, there is no current. So that's why the open circuit is the opposite of the current source. That's how you neutralize the current source. So again, for here, the V R prime prime is going to be just I times that R1 in parallel with R2. If you have never seen that notation before, that just means parallel. It's like the same as like geometry, I think. And you could write that out as it's like R1, R2 over R1 plus R2. And then your total VR would be these two added together. So VR prime plus VR, come on, R prime prime equals, yeah, it'd be R1 over R1 plus R2, V1 plus R1, R2 over R1 plus R2 times I. And so that would be your final voltage. It'll be good. So then I'm pretty confident that Thevenin equivalents will not be on your quiz this week because you only learned about them really on Wednesday. And generally what's on your homework is what's on your quiz. So yeah, I'll leave those for next week. And I'm just going to get into practice problems. So the first one I have lined up here is simply just writing down, it's a big circuit, and we're just going to be writing down equations as if we were doing mesh current. So I'm going to take a second to draw out the circuit. It's going to take a second. It's a hefty one. But the point of this question is to make sure that you know how to make your mesh current equations. I believe on your last quiz, you also had a question like this where they just said, write these equations down, don't try to solve. Generally, solving the equation like takes a lot of time. And if you know how to write if they're solving a system of equations takes a very long time if it's more than like 2 or 3 equations. But if you know how to write all the equations, then that tells us as the graders that you know the content. Because when it comes down to it, computers can do all of this for you. But if you misjudge the initial equations of the circuit, then you can't plug it into a computer correctly and you'll never get it. So yeah, let's say 4 ohms. I'm not going to write ohms. Ohms takes 6 and 8. This is Vx. This is 12 volts. This is 2 ohms, and that's 3Ix. Okay, cool. And then Ix is this. This would be 2Vx. So write all the equations. So what you got to start with is defining your mesh currents. So I'm just going to go, this is I1, this is I2, this is I4, and this is I5. It doesn't matter what order you do it in, you'll end up getting the same equations anyway, just with different numbers on your eyes. So starting with I1, just like I mentioned before, here it's very easy. We see that I1 goes through this current source, and it is the only thing going through that current source. So we can directly say that I1 equals negative 3 amps. For I2, for this one, it's just kind of standard. So I2, looking from the perspective of I2, that 4 ohm is going to be, I'll start with the 0 equals. So it's going to be the 4 ohms times I2 minus I1. And then for the 6 ohms, it's going to be 6 ohms. You can put the units in here, but it just makes your life a lot harder. Make sure you include units at the end. If you don't do that, you get points off. but while you're doing the math, it's really not that important. Another thing, when you're writing these equations, it's always going to be whatever current you are looking from the perspective of minus the other one. So if you ever write in the I2 equation and you do I1 minus I2, then that's not going to be correct, because from the perspective of I1, everything is going to be a positive I1. That's always make sure that the first term in this little like subtraction equation is the current that you're currently like looking from. And then that 2Vx, it's a voltage drop. We don't care about what that 2Vx is right now. We are just going to call it 2Vx. And so that's your second equation. Remember, always make sure to include that equals 0. Yeah. And then I'll do I3. I3, again, very similar to the last one. They're all pretty similar. It's just making sure that you know how to do it. So now it's going to be 2Vx because the current is going on this side, right? Our I3 is going up through that, and we have a voltage rise. If we want a positive thing is when the voltage drop is in the direction of current. Since we have a voltage rise in the direction of current, it is a negative 2Vx. And then plus 10, I3 minus I2. Again, if you look at this, these are negative of each other. Just keep going. And then we got 8 times I3 minus I5. And then we got plus 2 times I3 minus I4. Let's keep it going. It's just going through the motions right now. All these equations. 2 times, oh wait, actually, I almost made a mistake here, right? This is, again, we have a current source, and the current source is only attached to I4, so we can directly define I4. So here, I4 equals negative 3Ix. So yeah, if you get in that situation on a quiz and you start writing down your like 2 ohm resistor, I4 minus I3, and then you look at this and you're like, oh, I have a current source, just erase what you did before and you have the current. It's given to you, basically. And then we'll hit the I5. And I5, now we have a voltage source. This, even though there's a voltage source and it's only connected, it's still just a voltage source, so we still have to write the whole equation out. So here, we have a voltage drop in the direction of current, so this is going to be a positive 12 volts. And so we have positive 12 volts, and then I'll go to this 8 ohm resistor next, plus 8 times, we got the I5 minus I3, and then plus 6 times I5 minus I2. And so you might stop there and think, okay, that's enough equations to solve everything, but it says all equations necessary to solve the circuit in the question. I didn't really write that well, but when you're doing this, right, we have 5 equations, but we have like 7 unknowns right now because we also have that Vx and Ix. So we just have to define those real quick. And that's pretty straightforward. Ix, looking at Ix, so it's the current going through that 4 ohm resistor. And what that's going to be is that Ix equals your I1 minus your I2. Hopefully you can all see that because I1 is going down here. I2 is going up here. Since Ix is defined as going down, we're going to say I1 is positive and I2 is negative. And so that's your Ix. And then the Vx is going to be 8, your 8 ohms, times, since we've defined it with positive on the left and negative on the right, then that means that the current going to the right is positive, and the current going to the right is I3. So that's going to be I3 minus I5. And that's going to be all your equations for this question. On a quiz, that would be enough. What you can do here to check to make sure, we have 7 unknowns and 7 equations. So that means it's all the equations you need. You always, if you have X number of unknowns, you need X equations. So yeah. And then next question, I will do a superposition question. Drinking some water because I'm not used to talking this much. Okay, so superposition question. This is pretty similar to the example I did earlier, just with one more resistor and with actual numbers this time. So superposition EX. This circuit is much simpler. We simply have 3 resistors and 2 sources. We got our 12 volts, 3 ohms, 6 ohms, 2 ohms, and 2 amps. We got plus minus, and this is X. So as before, we're going to split this into 2 circuits. I'll start by neutralizing the current source, and then I'll neutralize the voltage source. So I can copy and paste things because I'm on an iPad. So I will copy this and paste. And I'll do the same thing over here. And so for this first one, I said we're neutralizing the current source. So we delete the current source, and it is replaced with an open circuit. And then we try to solve the rest of the circuit. So when I look at this, what I see is that since this is an open circuit, this whole part of the circuit does not matter anymore, because the only loop that we're going to be looking at is this one here. And this one is pretty easy to find, Vx prime. This one can be Vx prime prime. And remember, Vx equals Vx prime plus Vx prime prime. So here, Vx prime, by simple voltage division, is going to be our 12 volts times 6 ohms over 3 plus 6 ohms, which is 12 times 6 over 9, which is 12 times 2/3, which gets us to 8 volts, is our Vx prime. Oh, okay, wait, sorry. This will actually make the question a bit better. Find power dissipated. 6 ohm using superposition. So we have the voltage there. And then we can do the same thing on the other side. So here, instead of neutralizing the current source, we are going to neutralize the voltage source. And remember, when you're neutralizing a voltage source, you short it. So that means this has the same voltage on either side. So what that means is that this 3 ohm and this 6 ohm are now in parallel with each other, because this 3 ohm could be redrawn as like being down here, and the connections would all stay the same. So now looking at this, if you want to simplify the resistors, I'll simplify the resistors just to, if I were doing this on a quiz, I would put this whole expression I'll write down this expression that I put in my calculator. You can kind of see here that this is going to be, the 3 and the 6 are going to combine into like a V, or I'll call this like R prime. And then the total voltage across them would be that R prime over 2 plus R prime times 2 amps. Wait, no, that is, I just lied to you. I thought that was a voltage source. Okay, actually what we're going to do here is this is actually going to be current division instead. So like there's probably a couple ways to do this, but when I look at this, like I would just find the current going here, because you can do that, and then you can find like the proportion of current that goes to each side. I'm sure you could do this with like node voltage or something, but that just kind of feels excessive. Yeah. How do they do it in the, oh, they use mesh current. Okay, that actually makes sense. Yeah, I'll do that. Just as some more practice. I1, I2. Yeah, so this actually works quite well. So we're going to have our I1 circuit is going to be just 3 ohms times I1, and then plus 6 times I1 minus I2 equals 0. And then we have that I2 equals 2 amps. So then we plug that in, and we have 3I1 plus 6 I1 minus 2 equals 0, which is 3 plus 6 I1 is 9 I1 minus 12 equals 0. So then I1 equals 12 over 9 equals, it's just like 3.3. So now that you have your I1, then you have to plug that in to your equation for Vx. So Vx prime, or Vx prime prime, right? You can see is going to be that 6 ohm. It's going to be this term here. So it's going to be that 6 ohm. And since it says it's positive on top and negative on bottom, that bypassive sign convention implies that for the sake of this Vx, positive is the positive current is going down through it. So then we have that 6 ohm and I1 minus I2, which is going to be 6 times 3.33 minus 2, which is then, am I doing this right? Oh, wait, this is not 3, this is a 1. I thought that was like, I don't know what happened there. Okay, so this is a 1.33, so that's going to be 6, and then equals 4/3. So 4/3 minus 2/3, or 4/3 minus 6/3 is like negative 2/3 equals 6 times negative 2/3. That gets you a minus 4. So we get Vx prime prime equals minus 4 volts. So then together we get that Vx in total, remember this equation up in the top right, equals Vx prime plus Vx prime prime. And then that's going to be 8 volts plus minus 4 volts, which is 4 volts as our final answer for Vx. However, the question asks us to find the power dissipated by the resistor. So that's simply really one more equation. If you remember, P equals IR, but by Ohm's law for resistors, if we don't want to mess with I, this goes to I equals V over R. So then this goes to P. This goes to P. Why I keep like automatically writing an R. P equals B over R. Did I write that right? Yeah. P. I keep making little mistakes. This is not P equals IR. P equals IV. Power equals current times voltage. That is a thing. However, current equals voltage over resistance, and then we are replacing this I here with the I that we've gotten from Ohm's law, so that we get V squared over R. This just lets us skip a lot of math. So then here we get that power equals V squared is 4 squared over R is 6, which is 16 over 6, which is like 2.67 watts, which is a good enough answer. I kind of ran out of space there at the end, but hopefully you could see how that worked. Sorry for the kind of many mistakes along the way there. And then I can do any easy mesh current equation here. I could do, I'll do one more. Oh yeah, so another thing here, I think it's pretty likely that you'll have a question like this, just because this kind of makes you use mesh current as well along the way, which just kind of reinforces what he's taught you this week. So if you end up in a situation like this, think about using mesh current. You can do it other ways. Yeah. So I'll do one more question where it just asks you to write down the equations for mesh current. This one's a lot simpler. And then if you guys have any other things you want me to go over, I can. But if not, then that will be it. I really think if you guys make sure you know how to write these mesh current equations and understand how to neutralize sources, make sure you don't neutralize the sources wrong, then you'll probably be good on this coming quiz. I could try to like, no, I think I'm fine. 6 ohms. Okay. So this one's going to be, right, all equations to find x. So again, we start by just defining our mesh currents. So that's going to be I1, this can be I2, this can be I3. Remember, always try to make them in the same direction as each other. It'll just make your life a lot easier. I think the math should work out if you make them in the other direction or like in like weird directions, but you just don't want to have to deal with that. So that I1 equation, as always, we're going to have 0 equals, or you can put the 0 equals at the end, it does not matter, 2 times I1 plus 3 times I1 minus I3 plus 2. And then this voltage source is going to be it's going to be a plus because it's in the direction of current, the voltage drop, plus 48 volts, and that equals 0. The I2 equation is going to be similarly, let's start with that 48 volt source this time, but now it's in the other direction. So it's going to be a negative 48 volts. And then that's plus 2 times 2 times I2 minus I1. These two should be negative of each other. You can see that. And then plus 6 I2 minus I3. And that's all you have for that equation. And then I3, don't get caught off guard. You have the 4 amp source, and the 4 amp source is only connected to I3. So we can directly say that I3 equals negative 4 amps. And then it says write all equations to find IX. So we look at IX. IX is defined in our question as being to the right, and I2 is going to the right, whereas I3 is going to the left. So that means I2 is going to be positive. So it's just I2 minus I3. And now we have all the equations that would be required to solve it. However, you do not need to solve it because that would probably take a while. And it's more important to see that you know how to do this. Yeah. So if anyone has anything else they'd like me to go over, we do have a bit more time, but I don't know if it'll really help to just keep doing the same problems again.
I have a question.
Yeah.
So you write in the previous page, like you said about I mean not the practice problem, but it's about the superposition.
Mhm.
Um you write the two um like 2 pages about Vx equals to Vx equals to Vx prime plus Vx prime prime.
Yeah.
And the Vx prime is equals to V V1 times R divided by R1 plus
Mhm.
R2.
Yeah.
Yeah, that this is that this is what I'm asking about.
Mhm.
So why is VR prime equals to R1 divided by R1 plus R2 times R1, but VR prime prime equals to I plus R1 R2 divided by R1 plus R2. I know that
Yeah. I
the
get
second one
I
is
get what you're
about,
asking.
yeah,
Yeah, so the difference there is that for the equation on the left, we have a voltage source. I'll use some fun colors. We have a voltage source here and a current source here. If you remember, with voltage sources, it's just you're going to have a different way that the voltage is found. So with voltage sources, the way you find this equation here is that if you write a KVL loop here for this, I'll start with this equation with the circuit on the left. So you'd have that 0 equals negative, if I'm having a KVL loop like that, right? You'd have 0 equals negative V1 plus some current I. We don't really care about the current. I think it should cancel along here, along the way in our calculations. So you see that, right?
Yep.
You can rewrite that as like V1 equals I times R2 plus R1, right?
Yep.
And then, so then I equals V1 over R2 plus R1, right?
Okay.
And then if you were to find the voltage across this resistor, across just the resistor, which we've called VR prime, VR prime by Ohm's law is going to be V equals IR, and the I is V1 over R2 plus R1, and the R is that R1. If you rearrange the terms a little bit, then you just get R1 over R1.
Oh, okay.
Yeah.
I get it. I get it.
Yeah. And the way I did it here is basically what you can think of it as is each the way I think of it in my head is the voltage source, like if you have just a loop and you have resistors, the voltage source supplies that much voltage to the loop, and each resistor like gets a certain amount of voltage based on how big they are. So if you had like in this case, if you had, I don't know, I'll say just to make it easy, you have like 10 volts and then you have a 3 ohm here and a 7 ohm here, right? Then the voltage across this one is going to be 3 over 3 plus 7. This is the total resistance. This is this one's resistance times your 10 volts. So this one would be 3 volts. This one would just be 7 volts. Yeah. And then, okay, I'll leave that there. But that's voltage division. I believe you learned that towards the beginning of class, but like it's good to notice it when you can because it can make your calculations a lot easier. And then for the second one here, right?
Yeah.
What I did is I kind of skipped drawing a step. So this circuit can be redrawn as, I'll do it in 2 steps just to make it really clear. This is R1 and this is R2. You see, you just like kind of slide the R2 down to the left there. And this is like, I haven't changed anything here. This is still exactly the same circuit. I'm just doing this so that it's very obvious that these 2 resistors aren't parallel.
Okay.
Yeah. And then you'd combine the 2 resistors.
I understand.
Yeah. I'll finish writing it out just to, if people like look at the PDF that I upload or something. So then, yeah, your V R prime prime would just be V equals IR equals I times that R1 in parallel with R2, which is, yeah, the I times R1, R2 over R1 plus R2. Okay. Does anyone else have any questions about that or anything else? Anything like from the homework you have any questions about? Okay, in that case, I might end it there. Good luck on your quizzes. As long as you, I think as long as you guys understand really how to write the mesh current equations and then how to neutralize sources, then you'll probably be pretty good on this quiz. Yeah, okay. Good luck, everybody. Bye-bye.